Hello everyone, this is Engineer Selassie from Halo Academy and Brain Boosters, and today we are going to discuss about pile static load test. And if you remember, in our part 1 video we discussed about Anchorage type of system, because we have two type of pile testing. One is Anchorage type and the second one is crown type. And in this video I am going to discuss with you everything you want to know about the Anchorage static pile test system, and the full structural design procedures will be provided also. At the end of this video, I can assure you that you will know everything you want to know about the methodology and the structural design of crown type of static pile test. Thank you so much, and let's get into it. Okay, welcome back, guys. So as you remember, in our last video we discussed about static pile test using Anchorage type of system, and the link, I will put the link down below and you can check that video as well. But in this session we are going to discuss about the pile static compression load test using the crown method. Okay, this is the second method. So let's get into it. Now directly I will go to the design part. And for the structural design, this is going to be design of Anchorage system for static load test. And the reference which I'm going to use is, first we have to have the soil investigation report, and for the code I'm going to use BS 8081 1989 code of practice for ground anchorage. The test will be conducted in accordance with ASTM D1143194, and a very good book I advise you to read for all the pile design procedures, pile design and construction practice by Michael Tomlinson and John Woodward, 5th edition. This is mostly I am using these books. So that is what we are going to discuss. And so pile static compression load test procedure with its full step-by-step design of Anchorage system for static load test, and this is don't forget, this is crown system. So in this presentation I am going to talk with you first the reference part. I am going to discuss the reference part, then ground anchor design, then I am going to provide ultimate ground soil friction values and test pile details, load of anchors free and bonded lengths, okay, the free and the bonded lengths, the used strand property also presented, allowable strand capacity will be calculated, and we have two piles in this situation, equivalent standard diameter will be calculated, the allowable ground standard bond strengths will be calculated, the available bond capacity will be checked, and the same is true for the equivalent strand diameter for the second pile, also calculated, and the available bond capacity will be checked as well, and the allowable ground standard bond strengths will be checked as well, and the detailed drawing will be presented as well. So let's continue. Design of Anchorage system for pile static load test. So the reference will be soil investigation report and base 8081 1989 code of practice for grounding anchorage, and the test will be conducted in accordance with ASTM D1143194 pile design and construction practice by Michael Tomlinson and John Woodward, 5th edition. Ground anchorage design. The first thing is, according to the soil report, the following design parameters are used for calculating the bond lengths required to carry the test load. The first thing we have to check is ultimate ground soil friction values from the test report. So as you can see, we have layer elevation, soil description, design angle of friction, ground soil bond friction are given, and the degree and the soil description, as you can see, from GS to minus 4.5 Dubai municipality data. This is medium dense to very dense sand, and from minus 4.5 to the end, sandstone was observed during soil test. So the design angle was 35 and 42, and ground soil bond friction is 300 and 550. Okay, the second one is test pile detail. We have two test piles, P8 and P39, and the diameter is 1800. Cutoff levels are given, toe levels are given, working load and test load are given. The test load is 1.5 times the working load. You can multiply and you can find it. Then load of anchors. So we have two piles, P8 and P39, and the diameter is given. Test load is 13,230 kilonewton and now 9,140 kilonewton. Number of anchors, now the proposed one is for P8 there is 12, and for P39 8. So we start with this estimation number of anchors, and anchor load is equal to TL over A. That means we have 13,230, and this will be divided by 12, okay, and divided by, because the angle of the anchor will be 10 degree, so we have cosine of 10. So if you multiply this, you will get this. Then once you get anchor load, okay, from the test load, once you get the anchor load for each anchor, and we have number of strand. For each anchor we have 6 strand. I will show you 6 strand. So if you number of strand divided by the anchor, okay, number of strands divided by the anchor, this is 6. Then load divided by per strand, we're gonna get 1119.5 divided by 6, we're gonna get 186.6 per strand. This is the load on each strand. Then anchor free and bonded length, as you can see, free length, bonded length is 12 and free length is 8. It's already here. And diameter of the ground, the rig will this will be 0.5 meter, 1.5 meter. So factor of safety for bonded lengths, if you want to find the factor of safety, we have to multiply this. All the parameters are given here. Diameter of the ground, dg times pi times lb bonded length times fs over the load, okay, p. What is fs? Fs is here. As you can see from soil report, you can find the fs value, ground soil bond friction. So we are going to use, in our case, sandstone. This is 42 degree. This is the design angle of friction. So we will gonna use 550. So if you check for our two piles, we have 2.78 greater than 2.5, 2.68, and greater than 2.5. So we are ready to go. So the used strand property are Aston A416 grade 270. Section area is 140 millimeter square. Diameter DS is 15.24 millimeter, and ultimate tensile strength FU is 1,860 Newton per millimeter square. Modulus of elasticity is 192,510 Newton per millimeter square. So allowable strand capacity is equal to 0.8 times, this is a formula, ultimate strength, okay, times area of strand. So 0.8 times 1860 times area of strand 140. This is 208.3 kilonewton. This is greater than PS. What is PS? This is PS, you see. PS is here. So PS is equal to P over N naught. We already calculate 186.6. So it is already, we are already safe. This is greater than PS. Then the second step is equivalent strand diameter. Calculate equivalent strand diameter. This is ds square times 6. This is square root under square root. Then if you calculate this one, 37.33 meter you will get. Then the allowable grout strand bond strength, we are going to use 1 Newton per millimeter square. Factor of safety of 2 included. And the available bond capacity, this is equal to equivalent strand diameter times the allowable grout strand bond strength, Fg allowable, times LB. This is the length, bonded length. So if you multiply this, you will get 1407, okay, 1407.32 kilonewton. This is greater than P. P means this is for P8. We can come here, as you can see, P8, the load is 1119.5. So that's okay. Now equivalent strand diameter, again we calculate the same, ds square times 6 under radical, then 37.33 meters square. The allowable grout strand bond strength, we're gonna use 1 Newton per millimeter square as per the code. The available bond capacity, the same is true. We just multiply this, and if you go if you multiply this, 1407.3 kilonewton, and if you check the load on P39, 1160. So we are okay. So the number of anchors we provided is okay. Then equivalent strand diameter, yeah. So the same is true for equivalent strand diameter calculation, the allowable grout strand bond strength, and the allowable bond capacity for both. Done in this way, we know that our system is safe because it is in the allowable limit. It's very simple procedure, and we can simply get everything we need about our system, ground system, in this way. So the drawing, the detailed drawing also, as you can see, the detailed drawing, it contains, yeah, the detailed drawing. As you can see, we have what we have test crown, we have hydraulic jack, we have base plate, and the dimension is given. Okay, the dimension is given. This is 1.8 meter, this is 1.6 meter, and all the dimension, as you can see, this is 90 centimeters, this is 60 centimeter, and this is the cutoff level. We have minus 8.00 dmb. This is Dubai municipality data, and this is 10 degree. Okay, as you can see, it's 10 degree, and so this is free length, and this is bonded length. This is bonded length. So you can see like this to see the whole idea. So this is an example of, so as you can see, we have 12 ground anchors, 6 strand for each, and anchor load, as we have discussed now, 1119.5 kilometer. And if you want to see here, we have test pile, we have two piles, pile type, diameter, working load, test load, 1.5 times working load, and minimum concrete cube strings required at this date, 35 megapascal was required. Design concrete cube strings and 15 megapascal. So this one is minimum concrete cube strings required at test date. Okay, without achieving 35 megapascal, you will not start the design this procedure. So design concrete cube strings at the end of the day, it will be 50 megapascal. 50 megapascal. So this is the detail. We have also the second type here. As you can see, this is the procedure, this is the free length, this is the bond length. So all the allowable, everything is discussed, and this is how we design. So I hope this video was helpful. And thank you so much, and we shall meet in another helpful video. This is Engineer Selassie from Hero Academy and Boosters. Thank you so much.